we're going to be talking about today, and the other in the academy. I actually started my working career as a geography professor, my degree's in geography, and I gave that up because I wasn't very good at it, and I went back to business school and I got in the airline business. But along the way, I missed the classroom, and so I started teaching one school, two schools. This year, in 2 weeks' time, when I come back from Europe, it'll be 28. So I get to have a chance to visit with your peers and colleagues in B schools in this country, in Canada, and Europe, and Latin America, and occasionally in Asia. So to kind of as a preamble, start at the start here if we can. As a sort of a preamble, almost no piece of modern technology has had as much impact on the development of international business, that which you are about to embark on in this global project. Almost no technology has had as much impact as the jet airplane, the modern jet airplane. For more than 50 years, the modern airliner has preceded or facilitated the flow of investment, of information, of human capital, and much more. It has enabled global supply chains, the flowers on your Thanksgiving table in 2 days, and perhaps your holiday presents in a few more weeks after that. Thank you. Whole business models are predicated on the jet airplane. The successful women's retailer Zara comes to mind. Zara could not exist without the jet airplane. So it's a fairly impactful business. We tend to take sophisticated machines like a Boeing 737 or an Airbus A320 for granted, largely because they have become so common, so routine. They're like the power grid. You know, you flip a switch and the light comes on. It's always there. They're like a power grid. So the airplane or the network of air transport worldwide is like that power grid. You go to the airport, yeah, you have to deal with the TSA, but you get on, it's always there, it's always on. So we take it for granted. And it seems to me that in the internet era, we tend to minimize the movement of the physical. But most of economic development is not bits and bytes. It's the transport of people and goods. And the jet airplane accounts for nearly all of that long-distance movement of people. And by value, an astonishingly large percentage of world trade. Today's lesson, which is a kind of a fun case study that I've worked up over the past year, looks at a stunningly successful business that is at the root of this essential mobility, this mobility that we should not take for granted. This is a story about a huge JV that you've never heard of. But it happens to be fairly important when you fly, because every time you fly on a Boeing 737, and about half the time you fly on the Airbus counterpart, that's the one on the right, you're going to take wing with engines that are made by this joint venture that you've never heard of. Just to be honest, let's have a show of hands. Anybody heard of CFMI? One. Oh, a few. Okay, so a few of you have. So it's an exaggeration to say you've never heard of it. And look at this. How would you like to be a manufacturer with a 42% share? By next year, they estimate that CFM will have a 42% share of the civilian jet engine market. You can see a total of 24,500 units. CFM, you can see the other shares, Rolls-Royce at 11i, 42% share. That's not bad. I'd like that. Now, what are we going to do today? Okay, I'm going to start out, and I apologize to those of you who think that history is irrelevant, but I'm an old guy, and I happen to think history is hugely important. So we're going to have a little bit of a history lesson, talk about how this joint venture came to be. What were the circumstances? None of you were alive at the time of its formation. We'll have a little history lesson on that. Then we're going to talk about growth and evolution. over the 3 decades that this JV, this CFM International JV, has existed. And at the end, we'll talk about probably the most interesting part of this for you all, critical success factors. So all of you about to embark on your global project, or those of you that are about to go to work in an international business, might benefit from these critical success factors that we'll talk about at the end. Questions and discussion now. I've been apprised that you don't ask questions, which maybe that's too strong a generalization, so I hope you will. And apparently one of my predecessors, Professor Bush, called on people, which I think is kind of a nice idea. So you might think about that as a possibility. Okay, good. All right. So, but if you have a question during the presentation, please just raise your hand and cry out, and we'll deal with it. I have sent the school a PDF of these slides, so no need to jot down any of the stuff on the presentation. Now, we might start by looking at or listening to the CEO of GE, Jeff Immelt, who earlier this year said that CFMI was the best industrial joint venture in the history of the world. And I don't think Mr. Immelt is given to exaggeration. This thing has been incredibly powerful. You already saw that 42% market share number. Now Jeff Immelt says it's the most successful thing that we've done. We'll come back to that in a moment. So let's start with the history lesson. 55, 56 years ago, the first viable jet airliners took wing. Boeing had a machine called the 707. Douglas, now part of Boeing, had a machine called the DC-8. Started flying in 19... There's a nice, cute little ad. Americans jet flagships coast to coast in 4.5 hours. Now, within a couple of years, both of these two big companies, which already were dominating the airliner market, started saying, well, we're going to start building smaller airplanes. And the engine makers that existed at the time, Pratt & Whitney, General Electric, Rolls-Royce, we'll talk about them, saw an opportunity. In the 1970s, General Electric and the French company Snecma, they have, as we will see, formed this JV, which is now part of a big French conglomerate called Safran. These companies produced almost no civilian engines, airliner engines, only stuff for the military. And on the airline side, there were really two companies that dominated. It was Pratt & Whitney, based up in Connecticut, and Rolls-Royce, based in the UK. They dominated the market. So we're starting to see a ramping up in the early to mid-1960s, a growth pattern that has continued across the world in demand for jet airplanes. So there's opportunity. So they say, okay, we ought to try to cash in on this. Now, Snecma, this French company, they saw this opportunity. They wanted to get into the civil market. And they looked at the three possible players. They looked at Pratt & Whitney, they looked at Rolls-Royce, they looked at GE, and interestingly, this was an early example of collaboration that has now become quite common. The engine makers have collaborated substantially since then, mainly on the really big engines. So the A380, for example. Much of the A380 fleet is powered by an engine that's made by a couple of these. So early collaboration. Now, Pratt & Whitney was contemplating an update to one of its existing smaller engines that was selling very well. And Rolls-Royce, as a possible partner, was in financial disarray, essentially on its way to becoming a state-owned enterprise in the UK, largely because of some technological problems that they had in developing the engine that powers this airplane that no longer flies, called the Lockheed 1011. That Rolls-Royce RB211 engine was a very sophisticated piece of machinery back then. And they couldn't, simplifying here now, they couldn't get it to work. So they had cost overruns and da-da-da-da-da. Cost overruns on the military side, some of you that live or work close to the Pentagon know, that's never a problem for U.S. taxpayers. but in the civilian side, cost overruns are fairly critical. So Rolls-Royce was in disarray. They were not a potential partner. Now, when they started settling in, GE and this French company, Snecma, started talking more seriously to each other. They could see that they could, in fact, combine strengths to build a simpler and more efficient engine. Now, this word synergy, as you know, is sort of one of the business buzzwords in the last 20 years. It's abused a lot, but this truly was synergy. This was a situation where the whole would be greater than the sum of the parts. And how this would work was as follows. GE had developed some very sophisticated technology for the core of the engine. That's the part that gets hot. Okay, the core, the engine core. And they had developed that technology for a military app. And you can see that rather sleek and scary-looking vehicle in the middle of the slide, a B-1 bomber. And so the Pentagon had chosen GE for the B-1 bomber because it was a very sophisticated engine core. Now, Snecma had some additional attractive technology. So they're talking with each other. They say, well, you know, we could do this, and you could do that, and let's get together. The other thing at the bottom, very interesting, early example of companies recognizing growing environmental pressures. So this is now, we're in the early 1970s, and jet airplanes are much noisier than they are today. And so there was a lot of pressure around O'Hare, around Kennedy, around LAX, airports in the United States, not to mention all, for a quieter engine. And in a few years after the 1973 Gulf War, a more fuel-efficient engine as well. So environmental pressures driving market opportunity. Now, interesting here that, and we perhaps could leave this until the end in terms of critical success factors, but in laying out the history, at this point, important and interesting to talk about the role of personal chemistry. And very often, those of you that are students of the history of business, particularly these alliances and collaborations, will know that when the chiefs like each other, good things might happen. And so, in fact, that was the case here with this GE and Snecma deal. There was a great affinity between the head of Snecma, René Ravaud, former leader of the French Army of Resistance. Not as many of those folks as some of us might have liked. Trained naval engineer, highly respected guy in France. Well-educated, probably a graduate of one of the Grand Écoles. Very cool guy. And on the US side, on the GE side, a guy named Gerhard Neumann, GE's head of power plants. Neumann was, in fact, a former enemy alien, a German who had left Nazi Germany before things got really ugly and had gone off to Asia. A great story we won't tell here. But anyway, he had found his way after the war over to the United States. But in fact, in between, they had actually made him a citizen during World War II so that he could help out the Army Air Corps in Asia. Anyway, very capable guy, well known for both technical prowess and managerial expertise. Now, if you look at Neumann's autobiography, which is very fun, called Hermann the German, he says, the two clicked from the very first moment we met. And in fact, that personal chemistry may have played a role. The fact that these two guys get along really well. There they are in the upper right-hand corner. That's Ravaud on the left and Hermann the German on the right. And so Snecma selected GE as the partner. Now, to be fair, they had started to do a little bit of technical collaboration on a big sort of second or third generation jet engine called the CF6, a big engine that's still very much in use with airlines that fly 767s. Anyway, so they do the deal. Now, here's the first yeah but. Again, for history, we tend to forget about that unpleasantness called the Cold War. But the Cold War had made people in the United States very sensitive to the export of technology. And so the government was very wary. Both the Department of State and the Department of Defense recommended against the deal. And no less than Henry Kissinger, U.S. Secretary of State, signed the order in September 1972. It's the fine print, but you can perhaps read the White House at the top. It ain't going to happen. No, you can't have a joint venture. But they got a way to get it done. So French President Pompidou, Georges Pompidou, President of France at the time, appealed directly to Richard Nixon, and the matter was placed on the agenda of a summit that was held in Iceland the following year, 1973, and Nixon agreed to allow the export of this GE engine technology, but not without a whole lot of hoo-ha attached to it, okay? And you can see at the bottom, the deal required a very cumbersome assembly process. So you're essentially having to build something where, you know, we don't want you to look inside the core of the engine, the stuff that the Americans build, because that's secret. So imagine trying to, sort of build the engine and test the engine and sort of, a big chunk of sort of top secret in the middle of this, in the middle of this machine. Secondly, this is fairly interesting. I wonder, somebody here who knows more about military procurement may be able to update me, but this struck me as interesting when I was reading about it. General Electric was required to reimburse U.S. taxpayers $80 million because this technology that they had developed for the B-1 bomber was now going to make its way into civilian application, and they were going to make money on it. So kind of a nice, it's a taxpayer. I don't know how you feel about this. I thought that was kind of a nice touch. Okay. Boeing, by the way, has, through the years, never had this sort of burden placed on them. We can talk about that during question time. Separately, as part of this deal, the United States, and more specifically the people who wanted to advance the interests of both Boeing and Douglas, said, by the way, France, in order to get this deal done, you can't have any tariffs on importing planes from the United States. No duties. They come into the country duty-free. So when we sell Air France a 747, as we would like to, there's no customs duty due. So they got it done. Now, key to this, and again, this is something that we could talk about at the end during critical success factors, but for now, simple structure is key. And having worked in alliances on the other side of aviation, on the operating side, alliances, say, between American Airlines and British Airways, American and Cathay Pacific, simplicity is really good. Okay? And so simple structure was very, very important. It was a partnership of equals, 50-50 on ownership and revenues. And to this day, we'll come back to this at the end, to this day they maintain exact balancing in terms of both ownership, revenues, value added. Okay. 5 board members and 1 VP from each company. The president has typically been French, but has actually worked in Cincinnati, where GE Aviation has its headquarters. Now, CFMI, the joint venture company, if you will, would do 2 things. It would manage the program for GE and SNECMA, and it would provide a single point of contact for customers. Always useful when you have a piece of technology that requires customer contact, but there would not be a separate CFM sales team. So the SNECMA sales team was out calling, the GE sales team was out calling, and customer support teams equally. Each company maintained that as well. Now, you can argue with whether that makes sense or not. That's what they decided, and it seems to have withstood the test of time. So, very limited role for the joint venture company, if you will, the holding company, if you want to call it that. And as I alluded to a moment ago, the work would be split evenly. The engine is called the CFM 56. And the work would be split evenly. GE would build the hot part, where their expertise was in the core of the engine, the hot part. So that's called, in the technical argot of the business, high-pressure compressors and turbines and combustors, where all the hot stuff is, where the fuel gets burned. And SNECMA would make the front of the engine, called the fan, the low pressure parts of the gas turbine, and the nacelle, which is essentially the metal or nowadays carbon fiber structure that surrounds the engine, the part that you can see when you look out the window. And English, interestingly, how many people, are there French people here? Yeah, English, the working language, very interesting. You might want to, as homework, go and find out how that decision got done. But in any case, partly probably because on both a de facto and a de jure basis, English is sort of the language of commercial aviation. You know, when you land in Shanghai, they're not speaking Mandarin to clear you for landing. Okay, so English would be the working language, simple structure. Now, things got off to a very bad start, a very slow start. The first engine was built and tested in 1974, so that didn't take long. Remember, the deal got done essentially in 73. They already had a working prototype within a year. That's pretty fast, by the way. Actually, it didn't fly till 77, so a lot of ground testing. Now, initially, and this is probably pretty smart strategy for somebody building new engines, even though they're aiming this towards the civil market, towards airlines, they initially go after the military as people that, first of all, have pretty big checkbooks, and secondly, might be interested in buying the machine. So CFMI went after the United States Air Force that was building something called the C-17, a mid-sized STOL, short takeoff and landing. So this was not a bomber, this was not a fighter, this was a transport plane that the military used. It turned out that as that project, the C-17 project, evolved, the Pentagon chose Pratt & Whitney engines. Now, they did also look across to the civil side, because again, that's where they were going, but they thought, well, maybe we'll pick off what seems to be an early opportunity, and that is to re-engine, to put new, better engines on older planes. So to take those 707s and DC-8s that might be 15 or 18 or almost 20 years old and put more fuel-efficient, quieter engines. You can see at the bottom, that's a United Airlines DC-8 with new engines. That's a UPS DC-8 with new engines. And one of the reasons why they were looking at that re-engining opportunity was that Pratt & Whitney had already tied up much of the market. They were late. CFMI was late to the game to try to sell to Boeing for the 727 and 737s, the early models, and the Douglas DC-9. So there was no interest at Boeing at all. Boeing said, nope, sorry, no, we don't want it. And modest sales for Douglas. As I said, this is a DC-8 re-engined. This is a DC-8 re-engined, one UPS and United. That wasn't working. So then what happened? Well, they went back to the military. And the next target was to take the military version of the 707 that was a tanker, so a plane capable of refueling a fighter plane up in the air, called the KC-135, and re-engineering those, okay? So they went after the French, because the French had, you can see that, there's the airplane right there in the lower right. That's a 707 that carries gas, not people, okay? And so they went after the French, and the French ordered 44 engines, so 11 times 4, 44 CFMs, their first sale, 1978. They've opened the champagne. They've opened the beer in Cincinnati. They're dancing in the streets. They got business. 1980, big win. The Air Force says 2,500 engines. So essentially, the Air Force says, we're going to replace every one of our old Pratt & Whitney engines on the 135, the KC-135 tanker, with these new CFM machines. Big win, 2,500. Okay. And as they thought it would be, and as they had sold and marketed it to military and, more importantly, to the airline world, CFM said, this machine is going to perform. Now it's flying in quantity with the U.S. Air Force, and it does. Very quickly proves itself to be a superb machine. Fuel burn reduced 27%. That's a huge number. takeoff noise reduction of 98%. A 98% reduction in noise. You didn't want to live near the Air Force Base before they bought the new engines. And if you think I made a math error there, takeoff noise from 126 to 99 decibels, the decibel scale is logarithmic, exponential, so that's actually the right number. So huge reduction in fuel burn, huge reduction in noise, huge improvement in performance. Now the airplane can take off with 3,100 feet less concrete. This is all physical stuff. This is not the virtual world. This is engineering. And this is an amazing breakthrough. And lastly, the fact that this machine, the CFM turbine, had a simpler design greatly reduced the maintenance expense. And so, as often happens in the world of aerospace, people want to see the thing in action. They can read about what the engineers promise in terms of fuel burn, but they want to see it fly. What is it doing? How much fuel is it burning? How much noise does it really make? And it's A+, 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 A+. So they're onto something. They knew they would be, but they have to show it. A little bit like those of you, if you're interested in this sector, the Canadian company Bombardier is building a small to medium-sized airliner called the C-Series. Sales have been very low, disappointingly low, partly because it's a brand new airplane and it hasn't flown yet. So when they deliver their first planes next year and it performs as they expect it will, sales will probably improve. So they prove it. It's got potential. Questions? Yes, sir. Good, thanks.
What's the lead time on an engine?
Lead time, I mean, how long does it take to build one?
So they placed an order. How long until they actually had the engine in for the Air Force to actually...
Probably. In this case, they had already flown it and proven it, so it was probably less than a year. Yeah, very short, fairly short. Questions? Thanks for that. So they've got some business. The machine is performing as they wanted to, but the sales are to the Air Force in France and in the United States, and they still haven't cracked the civilian market. But oh my, what happens next? Well, a huge, huge breakthrough. In 1981, Boeing says that the CFM56, the machine that the JV is producing, is going to be the sole engine type for its next generation of 737s. Okay. I'm going to come back here because my hearing is getting kind of bad. Sir? Right. Yeah, they absolutely are. They absolutely are. I mean, GE is. Well, because they don't have an equivalent. They're not competing against themselves because they don't have a smaller engine. A sweet spot. Correct. Yeah, that's exactly right. So what they were doing, so when they had the opportunity, it's a great question, by the way. When they had the opportunity, they thought they might have the opportunity in the early 1960s to build a smaller engine. They were focused on military and they were focused on others. GE was. So they said, well, we're not going to build one. Then when SNECMA came to them and said, we think there's a market, let's go, they didn't have a smaller engine, so they're not fighting against themselves. This becomes, the CFM56 becomes not their smallest, but their engine in this size market. They actually went on and have become hugely successful in the smaller market, these so-called regional jets that hold 50 people. GE's got a big part of that business. Under their own line. Because this CFM56 is only for these, for the most part, for these mid-sized, narrow-body airplanes. Okay? So great question. So there's a breakthrough at Boeing, the exclusive provider. So Boeing says, if Boeing goes out and makes an offer to United or to British Airways or to Lufthansa or Qantas and says, if you're interested in the 737, 300 series and beyond, we've got an engine for you already. And they said, well, no, we'd rather buy the Rolls engine. No, can't. And this was a very interesting example. It's done a lot on the military side, but this is the first example on the civilian side of sole sourcing. In other words, Boeing saying, if you want the new 737, it only comes with CFM engines. Okay? And you can see the numbers here. So the first of these newer generation 737s, the so-called 300, 400, 500, 600 models, which were in production for almost 20 years, 2,056 airplanes, and add on some spares, because you got to have spares. So 2,056 airplanes, which translates into about 4,300 CFM engines. By the way, in case you were wondering, right now, these things are about 10 million a pop. So rough numbers, depending on the kind of deal you're negotiating, a CFM 56 engine is going to cost you 10, 11, 12 million dollars. A lot. So you can do the math here. It's just some big business. But then Boeing really starts to get traction with their so-called next-gen 737s. Like that one up there, Americans got I think almost 200 of these. So-called 700, 800, and 900 series. Here, these are all still in production. So they're all still being built and churned out in Seattle, Washington. And you can see the deliveries. This is through October, about 7,000 airplanes, which equates to almost 15,000 engines, including spares. Sir, thank you. Yeah. It is. It turns out to be. You're right. I mean, there's a great question. There's a risk, right? There's definitely a risk there. There's a technological risk, right? Well, is it right? But there's also an economic risk, because it's sort of handing things away. And you could probably. I don't know much about what the thinking was at Boeing at the time, but I'm sure they looked at that. But what's interesting is that this is a first example of something that happens quite a bit now. For example, even further down the food chain, let's take a simple example that you can probably relate to. So these seatback movies, right? The screens, right? The so-called IFE, in-flight entertainment companies. Airbus, for example, has, I don't know if it's a sole source, but they have, I think 2 producers that they'll deal with, right? So you can't buy it from these guys over here. You can buy it from IFE company A or B, right? Yeah. So yeah, but you're right. There's a lot of issues that are interesting here. So Boeing has now from 1981 onward done CFM an enormous favor with it, and not a bad deal across the way. And remember, folks, you guys know this, but I perhaps should sort of make it very clear now. Remember, when you go shopping, if you're an airline, back when I was at American, I reached into my pocket, we've got enough money to go shopping for there's only 2 stores, right? 2 stores for big airplanes, right? Boeing and Airbus. So they got these guys, and they've got a nice deal at Airbus. They weren't the sole supplier, to your point. Airbus said, no, we're not, we're going to make it possible to buy from other people, although it turned out that other people was only one other manufacturer, a company called IAE, which is one of these joint ventures. So CFM has got about a 55% share of the narrow bodies, A318, 319, 320, 321s, essentially the same airplane, longer or shorter. And then 20 plus years ago, they also were providing engines for the A340, which you don't see anymore, 4-engine, long-range, bigger airplane that Airbus no longer manufactures. And you can see the numbers there. You can see I've got it broken down, I guess a little bit too much detail here, but got it broken down by engine type and aircraft. See the engines. So here we got now through December of last year, next month when they update the data, we'll have an even bigger number, but you've got 8,400 engines delivered on the Airbus side. So if you're keeping track times, say, 10 million as the price, you're thinking this is pretty good business. Now, those of you that are interested in technology, and maybe those of you who are afraid of when you fly, what happens if the engine blows up, should be reassured by this side. This is possibly one of the most nearly perfect machines that humankind has ever produced. These engines, these CFM engines, routinely operate for about 25,000 flight hours, which is roughly 6 years, with only basic maintenance, meaning the mechanic goes in and adds a quart of oil, meaning they do some little tinkering with some wiring here or there, but it's just basic maintenance. 25,000 flight hours. The on-wing record, or that phrase in aerospace called on-wing, means just that. The engine stayed on the wing. It didn't have to be taken off and taken to the shop. The on-wing record is from a German charter airline with a little smiley tail there, TUI-Fly, 50,000 hours for this engine. The plane was delivered in 1999, and it went from 1999 to 2012, and they didn't take the engine off to repair it, but only to replace some of what are called life-limited parts. So after 50,000 hours, some part of the engine, you just, for prudence sake, you need to replace the parts. It wasn't broken. It wasn't broken, and it had flown for 50,000 hours, carrying people all over. In-flight shutdowns, you can see the number there. That's a number that maintenance people and other people in the airline operating world look at. 1 per 333,000. It's essentially the machine does not fail. The machine does not fail. And part of the reason this is because the digital revolution that we've been talking about a little bit here has found its way into the jet engine. And there's a lot of very sophisticated sensors throughout the machine taking temperature and monitoring pressure and monitoring oil consumption, all kinds of other things, what's called ECM, engine condition monitoring. So these sensors are taking all these data points and are uploading them either to the airline or to the engine maker or to the maintenance provider if it's a third party that's responsible for maintaining the engines. So it's an astonishing machine. And, one thing leads to another. A great machine with terrific fuel numbers and noise produces sales. Sales produces more in service, more reliability, more flying hours, more. Success begets success. Now, interestingly, since inception, more or less 40 years ago, CFM has developed essentially 4 models. They're all about the same size. If you looked at them from a distance, you wouldn't be able to tell them apart, but the more recent ones, the newer ones, are more powerful to fit a range of needs. And in the 2000s, they didn't just build this machine in 75 and leave it alone. They were constantly improving on the margins, not the core of it, not the basics, but on the margins. So some improvements to improve fuel efficiency, reduce pollutants and noise. But the biggest effort has been to develop this new CFM so-called LEAP engine. And you can see it there on the test bed of an old 747. So the engine has been built and testing. It's flying. I think this picture of first flight was from a couple of months ago. This new LEAP engine, a lot of technology coming out of what GE had learned in developing these ultra-large engines for the 777 and the A380. But SNECMA also coming forward with a lot of stuff as well. And it was to use again a little bit of terminology, it was an evolutionary design. Pratt & Whitney is making a big splash with a fundamentally new technology called geared turbofan, which essentially means that there is more than one sort of set of things spinning. And so the thing that's in the front, the fan, is spinning at a different rate than the core of the engine with a gearbox. More complexity, but they think it's going to be the answer. CFM says, too complicated, we like our evolutionary design. And look at this, another 15% improvement in fuel burn. So when you thought, well, you're starting to reach the upper limits of efficiency, and Newton's laws of thermodynamics are entering in here, they've managed to squeeze another 15% out of the engine. And on that basis, and on the proven track record of thousands of these delivered, they have already sold 7,500, and not a single one's been delivered. And if you're curious about this, you can Google CFM LEAP engine, and you can read the press releases or go to the CFM website. They just keep selling more and more. Yes, sir?
Now, is that ability to sell these in advance because it's just an evolution off of an already tested and true product?
Yes, exactly. And that's a very good point. So this Pratt & Whitney machine, which is a very elegant machine, is brand new, unproven technology. And so if you're a salesman for, GE or SNECMA, and you're out calling on airline X, you say, well, you don't diss them. You might. But you sort of say, well, there's not a lot of proof here. And the Pratt engine on the Bombardier plane up in Canada, the C series, has had some issues. Now, I don't know if that's related to the new technology, this gear, this fact that it's got a transmission essentially or not. But it is. But certainly CFM says proven technology. We're not going to mess with the basics. The basics have been working for 40 years. Yeah, good question. So 7500 is already sold, first into service in about a year and a half. They are moving forward. Okay, let's finish up with a discussion of critical success factors. Okay, and I think there's a couple of slides here, and then we can throw it open to question time. One of them is, and I alluded to this when we were talking about personal chemistry with Revaux and Herman the German liking each other, but they had in fact done some collaboration. They had worked a little bit. They hadn't formed a joint venture, but they had worked a little bit. They had exchanged engineers on the so-called CF6, on General Electric CF6 engine. This is the big engine for 767s. So that was probably helpful. Secondly, this very lean structure. So the JV is not going to have a bureaucracy. It's not going to have a separate sales team. It's not going to have separate customer support. That's going to go back out to the respective companies. CFM is going to essentially be a headquarters. It's essentially going to be people that organize the work and keep everything humming along. So very simple and very lean structure. As we said earlier, third point that makes it work, almost perfect equality. 50-50 ownership. Nobody's got 50.1 and the other 49.9. And it's kept and rebalanced all the time. And near obsession, when you talk to the GE folks and the Safran SNECMA folks and say, what makes this thing tick? What makes it work? They say, we're really focused on a true joint venture. Nobody's even just a little bit bigger than the other partner. 50-50, okay? And that also means equitable division of work and the will and flexibility to change over time. So a certain willingness, and we'll say more about that in a moment. So that's point 3, perfect equality, 50-50 down the line. Number 4, an interesting point, aerospace industry culture. The men and women who build these machines, whether they're gas turbines or they're airframes or they're smaller components, avionics, cockpit equipment, all this stuff. There's a culture about them that is pretty similar worldwide. It's a culture of precision. It's a culture that's obsessed with safety. General Motors might learn a little bit from the aerospace industry. But the fact is that this culture is pretty similar, and it's sort of a given. People, again, it's one of those things people that work in the business don't pay much attention to. But if you're outside the business looking in, and you go talk to people at MTU in Munich, or Rolls-Royce in Derby, England, or Mitsubishi in Tokyo, people that are making stuff in aerospace, cultures are very similar worldwide. National culture is different. Organizational or industry culture, very, very similar. And that's an interesting point. Number 5, something to be said for some of these basics. Trust, respect, and friendship. Taking these very different traditions, very different aspects of ownership structure. My bad, I haven't said something that I should have introduced earlier on. SNECMA, now owned by Safran, is a state enterprise. So the French state owns SNECMA. So 50% of the JV is essentially owned by French taxpayers. GE, of course, is a privately owned company. Very different corporate culture, state-owned, private. But they've been able to build together something that works very well with enormous amounts of respect for technological and commercial expertise at the two companies. A few more. One of them, and again, this gets a little bit into the weeds, but when you make things, particularly when, this party is responsible for this part of the machine, and this party is responsible for that part, you have to work together on how you're going to build this. Now, the end of the Cold War has made it easier, and some of those rules that were the original precondition for assembly have been relaxed. But you still have to think about how you're going to ship parts across the ocean in one way or the other, so aligning the manufacturing procedures, essentially creating a manual, if you will, or a Bible, if you will, on how to work. So 150 operational rules that are updated, but almost unchanged since inception. And again, here's proof of a very well-designed collaboration. These 150 rules that sort of govern how the machine is manufactured are unchanged in 4 decades. A lot of cross-fertilization among mid-level managers is always important. It's one thing to have the C-suite guys and women go back and forth. But what about mid-level engineers, managers, commercial people, back and forth between France and Cincinnati, except in August? So a lot of that going on. Number 7, clear understanding of competitive threat. Okay, and even though the structure of this industry is probably oligopoly, right? There still are competitors out there. And there's still opportunity, for example, for collaboration among the 4. And there's the likelihood that there will be new entrants coming in as time goes on. The Russians and the Italians are building an airliner and a jet engine manufactured in Russia, so on and so forth. So understanding competitive. Pratt & Whitney, we've already talked about their revolutionary geared turbofan as a threat to the CFM franchise. We've already mentioned number 8, success begets success. The fact is that after those first big sales, the two companies really said, look, we've really got something here. We better focus on it. So to both companies, it's important. Now, GE is a vastly diversified manufacturing behemoth, right? Aviation is an important chunk of what they do. But it's just one chunk. But I can tell you that GE Aviation has Jeffrey Immelt, the CEO's attention. They're focused on it because it's been so successful. And interestingly, earlier this year, the joint venture agreement was renewed for another 25 years. Runs to 2040. So imagine 2040 will come along. And so they've been together since 1975. That's a lot of longevity. That is an impressive commitment. And lastly, the importance of alignment at the top. I mentioned this a moment ago. So the CEOs growing up together with the project. Not the CEO of GE Corporate, not Mr. Immelt, but GE Aviation by itself. If you disaggregate, it's an enormous business unto itself. And the CEO there and the CEO at SNCMA, for the successive CEOs in those organizations, have sort of grown up together with the project. So taken together, you can see simplicity, great collaboration, building of trust and respect. I mean, when you talk to these guys and you say, well, what's the downside? Call Cincinnati and say, well, what's the downside? And they go, well, and there's a long pause at the other end. They go, well, you can't get anybody over there in August. I said, you mean because the French take long vacations? Yeah. I said, well, so that's not a big deal. He said, no, that's fine. I mean, you really have to, I'm going to dig deeper into this as time goes on because I want to know more. But so far, I haven't been able to find, much that's not to like about this. Now, if you're wondering, what else might it do for you? Those of you that track GE corporate performance, you may know that earlier this year, they were proposing a big deal, another joint venture with another French company called Alstom. And there is no question that CFM's success in getting this deal done had a lot to do with the fact that they had proven themselves. GE's success, they had proven themselves with CFM. There's no question. And in fact, early in discussions, the economy minister in France, he's gone now, but at the time, praised the CFM venture and suggested that if they balanced the partnership a little bit more towards the CFM model of 50-50, that would be better than an outright takeover. And in fact, that is closer to what came to pass. The final agreement between GE and Alstom is much closer to the CFM structure than what GE first proposed. There are a number of 50-50 JVs that were carved out, whereas before GE said, no, we're just going to buy that Alstom business. And the French said, maybe not. So they've gotten closer to the old. So a nice dividend for GE because they really wanted to get this deal done. It's actually over on, principally on their power generation business, the part of GE called Water and Power, but also has a little bit of spillover into their railway business as well. So an interesting dividend for them recently. So does it pay to work together? Absolutely. And with that, time for additional questions. Yes, please. Sure. How they make decisions. So they have to reach consensus.
So they are 50-50 in their controlling power over the CFM. And they have this lean structure, but they make very quick decisions. You can see in 1 year they come up with a new model. How that happens? It's a state-owned company in France and a private company in the US. How that happens?
Well, I think it comes from, probably at the beginning in 1973, 74, 75, it wasn't as easy to do as it is now. But now, with 40 years of experience, they just know each other really, really well. I mean, the analogy that was, somebody says, it's like a hand in a glove. I mean, that's not the right one, but I mean, it's very, very smooth. So they've really thought through not just decision-making at the top, right? But they've thought through, for example, how to cross-pollinate at middle levels. And those of you, if you've taken taken an OB course here or an HR course, or if you have experience in large organizations, oftentimes in the middle is where you get trouble, right? The so-called concrete middle. And so here what they've done is they probably could anticipate that there might be, the kind of body language resistance like this, right? So they said, okay, well, we're going to get an exchange program going, like in high school. Send the engineers from Cincinnati over to France, introduce them to high cuisine, send the French engineers over to Cincinnati and introduce them to Chile. Any of you that are from Cincinnati know what I'm talking about. Skyline, yes! Anyway, so that's basically it. That's really what's going on there. I mean, there's probably more to it. And as I said, as I dig more into this, I'll probably start to understand to the extent that they're willing to talk with me about what causes this. But for now, what I understand is that it works like that. It's very cool. Good question. And by the way, thanks for that. Check it off. Where else? Yes, sir. Yeah, it's a great question, and I think time will tell. And I will tell you that there's little doubt that the engine makers, whether it's GE on its own, or Snecma on its own, or across the way at Rolls-Royce or Pratt, or not at Pratt because they've got one, but everybody's working on potential new technologies. The reality is that so far, and I should put in some numbers on this based on your question and the next time I present this. But so far, in terms of the narrow body 737 planes and the Airbus A320 series, so far, my sense is that CFM has got about 75% share going forward in that narrow body market, as against Pratt & Whitney with this geared turbofan, 25%. Now, again, part of it is that this Pratt machine does not have, it does not have any track record. And see earlier discussion, remember what I said? Once the thing starts flying, two things can happen. It's either going to be better than expected or not as good as expected. And typically nowadays, things are probably going to be better than expected in terms of fuel burn and other things like that. By the way, the Pratt technology, there's no question, is superior in terms of noise. It's much quieter. It's much quieter than the new CFM LEAP engine. But, anyway, interesting. But it's a great question. What else? Yes, in the back.
So typically in the software space, when you have a product that's successful, you get a lot of talent poached.
Uh-huh.
Do they face that problem that key engineers or particular managers were being taken? Why wouldn't Pratt & Whitney or Rolls-Royce?
Yeah, it's a great question. The short answer is I don't know. I think that there are, to a certain degree, my guess, my speculation, I should dig this out to find out. My speculation is that although there may be some amount of mobility, the fact that these enterprises are essentially national in nature. I mean, they're global in terms of sales, but they're essentially national in nature. Rolls is a UK company. Snecma in France, GE and Pratt in the United States. There may be, the friction, both cultural and just practical things like visas and work, that kind of thing. But so I don't think it's, you're right. I mean, there'd be a temptation for that. But again, part of it is, remember, these things are, this technology is, even though I might call the Pratt engine revolutionary, this technology is all still really fundamentally, it's not disruptive, right? It's really evolutionary. I mean, we're dealing with physical processes. We're dealing with, burning jet fuel and turning it into a vacation in Hawaii. I mean, this is physical stuff. Yeah, different from the kind of world that you probably work in, where somebody, really bright invents, HTML and the world changes, right? Yeah. What else? Any other questions? If I can't see, it's a big audience. If I can't see, you just yell, "Yo, Rob." I think we're done. Okay, we are at 1:30. Thank you. Thank you.